says that a hiker climbs up a steep bank, all right? And you're just matching the picture with the story. Then all of a sudden, what does the hiker do?
He rests.
Well, he doesn't fall, but he rests for a minute. So that's where, so you're talking about his elevation. He stays like at a flat level, okay? Now, the problem with B means he just gave up and he quit and he stayed there for the rest of the day. But our story moves on, all right? He then walks up a small hill, so it's not as steep. All right, so it looks like either one of these, it could be. Now let's see the very last part of our graph. Then what does it say? He reaches a flat plateau. Which one of these two looks like he reaches a flat plateau? A. So he didn't go any higher. All right, is everybody good with A? I meant with number 1. Okay, number 2. All right, it says we have these ordered pairs, and I know a lot of y'all didn't like all these function rules. The good news is it's multiple choice, so you're just trying to see which one fits. Yes?
Could we do if it helped us, could we do a little chart thing?
On this? Yeah, and on the ACT, a lot of times on these kinds of problems, they call it plug and play. You plug in numbers and see what works. And that's what I would do, okay? Especially since we haven't learned any of these until some of these Algebra 2, all right? What you're going to do is, let's start with our x value of 1. All right, we're just going to start with A. If I plug in 1, what is 1 squared? 1. 1 times 1 is 1. Does that one work out? Yeah, plugged in 1 and I got 1. Let's try the next one. Let's plug in 2. What is 2 squared?
4.
Did that one work out? Yeah. Now let's try the next one. If I plug in 3 squared, 9. Do y'all see what I'm doing here? I'm plugging in the x value and seeing if it equals the y value. Well, it just so happens that it is A. But I want us to imagine, let's pretend we tried C first. If I plugged in 1, what's 1 plus 2?
3.
Did that equal that number? No. That's how you know that didn't work. Okay? Do I need to show you another one? No, we understand? Just plug in the numbers and see what works, okay? All right. Number 3, and y'all be careful on these because this is a set of 4 problems, okay, that you're going to want to make sure you get it right from the beginning because it might mess up, the next few problems. So what's the perimeter?
The area or the thing around.
Yeah, you count all the way around it. All right, I want you to notice something. Notice how in each triangle, do y'all see that there's 12 at the ends every time? Does everybody see that? There's a 6 and a 6 here. Then what this one have? It has a 6 and a 6. And what does this one have? So we always have 12 at the end. So I want everybody to keep this plus 12 in mind. Now, as I increase my triangles, it goes from 5, and then I increase it by what?
10.
Well, I go to 10, so I increase it by 5. Then what do I go to?
15.
So I increased it by 5 again, right? So that's one way we can look at it as we're adding 5 for each triangle. 5 for each triangle. So if you'll look at this, we're saying 5 for each triangle. I'm just going to call it T, but I always had that 12 there, okay? Does that make sense? Every time I add a triangle, I'm increasing it by 5, but I always had my 12 at the ends. So you're kind of looking for a perimeter or a formula that fits this.
Should be D.
Yeah, it's D. I used T. I know they used N, but I wanted to use T for triangles. And if you see that, if I plug in 1 for T, what's 5 times 1?
5.
And what is 5 plus 12?
17.
And if I added that, I would get 17. So see, you can plug and play these two. Like you can say,
All you have to do is add 5.
yeah. Yeah, so you would know each time you're adding 5. And that kind of takes us to our next question. Any other questions on this one? It'll be on the video if you need to watch it again. Number 4, this is why I said here we're about to look at our next question. Now it says, suppose you know the perimeter of your triangle and then you go to the next triangle. That's what this means. Like I had 3 triangles, then I go to my next triangle. How would I find the perimeter? What did you say? What did you just say, Jaden? You would add 5 to it. Okay? Every time you're adding 5 to it. So that's going to be A on number 4. Does that make sense?
D, right?
Huh? Yes, number 3 was D. Now I want you to try number 5. See, it goes with this. And I started it already. If there's one triangle, what's the perimeter? 2 triangles, and fill in your table real quick. Make sure, take a second to get it right because this affects your next problem. All right, so you're just filling out your table. Did y'all get it already? Mm-hmm. Still working on it? You know what we're doing, Aston? Yeah, okay. I thought you were asking a question. I'm just adding up what's around my first triangle. Adding up what's around 2 triangles. Adding up what's around 3 triangles. And putting that there. Okay, what'd y'all get for 1 triangle?
17.
Okay, that's right. What'd y'all get for 2? 22. And then what'd we get? 27. Any questions? Anybody not understand? Now, if you flip it to the next problem, this is graphing your table. So if you just messed up, what's going to happen on this one? You can still earn partial credit. Like if you graphed what you gave me, you get partial credit, but you want full credit. So, all right, so what you're going to do on this one is go over 1 and then up how many? 17. So I don't have the exact number, but I can tell it's about right there, right? Then where am I going to go? Over 2 and up how much? 22. We're just using our table. It's about right there. And then what? Over 3 and up 27. And you notice we're going up by 5s, right? So you could go back to question 4. Say you didn't know how to answer question 4. Now would be a time to go back and say, hey, I know what I was doing. I'm going up 5 every time. And now you can answer question 4. You don't have to. You can't. I mean, this is all they're wanting. And you can keep going or you can stop here. I can see you've graphed and you can see your line. Okay. How are we feeling? And you know, number 7 is not on there because it's just asking the same thing that number 4 asked. Okay. So let's go on to number 8. Is this a function? A linear function. What does a linear function mean? Does it make a straight line? Because it can be a function and not be a straight line, right? We had several of those today. This is a function, but is that a straight line? No. So it's asking, does this make a straight line? Does anybody remember how to tell?
You have to like subtract the figure and just see how.
Yeah, very good. I mean, one thing you can do is graph it and see, but y'all, that's time consuming. So what you can do is just see, okay, are you going up or down the same amount every time?
Yes.
Okay, and so how much are you going up or down? You're going down 7 every time. Does everybody see that? What's 46 minus 7? What's 39 minus 7?
32.
What's 32 minus 7? So it's linear because you were taking the same steps every time. So if you drew a line, it would be straight. Okay? Kind of like this last graph, we were going up 5 every time, so it made a straight line. Are we good? Yeah. So it's yes. That's all it was looking for. Yes. Number 8's just with that table. Okay. Number 9. Do y'all remember how to graph?
Do we use our own numbers?
Yeah. You can use your own numbers.
Do we need to draw like a little chart thing?
I would, just so I can see what your numbers are. If you don't draw a chart, then I clearly need to see the dots where they go. Okay, what numbers would you pick?
0, 1, 2.
0, 1, and 2. That is also what I would pick because those are what? Easy numbers to plug in. All right? Whenever you're graphing, if you pick some X values, you can find some Y values to go with them. Are y'all warm?
Yes.
There we go. Y'all, all you have to do is say something. Okay. So let's see, X and Y. Here's our little table. So I'm just going to pick some numbers. All I need is a few. And then we plug them in, and we have some ordered pairs. So if I plugged in 0, what's 3 times 0?
0.
0 minus 2, because I still have that minus 2. What is 0 minus 2? Any questions, y'all, on that one? On where I got something? No? We're good? What am I going to plug in next?
1.
My 1. What's 3 times 1?
3.
And 3 minus 2.
3.
And y'all, it should make a straight line, okay? All right? If it doesn't, we've done something wrong. So that one was -2. That one's 1. Then my next one, if I plug in 2, what's 3 times 2?
6.
And 6 minus 2 is
4.
4. Now, how do you plot these points? Do y'all remember that? No?
You go over 0 and
That's right. Down 2. So this is your left and right, and this is your up and down. So I'm going to go over 0. That means we don't go over any at all. But then I still have to go what? Down 2. And that's my first point. And I'm going to do that every time. Now on this one, what am I going to go over? 1. And, yeah, it means you go to the right. And then what? Up 1. So I go over 1, and then I go up 1. And then my last one, what am I going to do? What are my 2 numbers?
Over 2.
And that's right, over 2, up 4. If they're positive, you go to the right or up. If they're negative, it could be left or down. So over 2, up 4. And does it make a straight line? Yes. And just, you know.
So you need to draw a line.
Yeah, on this one, I mean, if you don't, I'll see it. But in the next chapter, this is what we're doing. You're going to learn all different ways to graph equations. Okay, and we'll go over this one again in the next chapter. And it keeps going forever and ever, right? Because I can continually plug in. I could have plugged in 1,000,000 for X and gotten an answer. I mean, I don't want to do that, but so it just goes on forever. All right, I want you to try number 10 and see if you remember.
Gonna check mine?
Your number 10? I'll check it. Yep. I'll pause this while y'all try it. I like a little discussion to go with math. Now, so you sell DVDs for $11 each. What's the cost of N DVDs? What 2 letters do they want you to use? N and C. Okay, so try to use N and C. So the cost is how much per DVD?
11.
11. So you're going to write the cost is 11 for however many DVDs. Because if it was 1 DVD, how much would it cost? 11. If it was 2 DVDs, it would be what? 22. So you can kind of think about it to make sense. Yes, Shirley?
I wrote it backwards. I put 11 in equals C.
That is perfectly fine. It's the same thing. Okay, I'll take that either way. Now, don't forget this part. Make sure you read your directions. Is it continuous or discrete? Discrete. Why is it discrete?
Because it has points.
It's points. Can you buy a half a DVD? No. Okay, you wouldn't do that. So you can't buy pieces of the DVD. So it's, yeah, I mean, I guess you can make art with it. But it's discrete, okay? You would put discrete. Continuous is going to be something like weight, like produce. Can you buy a half a pound of something in produce? Yes. Okay? Or a quarter of a pound. That's when it's continuous. All right, then the next one, write a function rule that gives the total cost of sugar. I need to read it here, I can't see. If each pound costs 59 cents. When it says each, what did I tell you you're doing with that? Per, each, you're multiplying. Do y'all remember? So for this one, what do you get? The cost is 59 cents per pound. Yeah, it's D. Don't let A confuse you. A is saying it's how much? $59. Is anybody going to pay that? No. Not yet. We're not there yet where it's that much. Okay. A snail travels at a rate of 2.35 feet per minute. Write a rule that describes the function. So you're just writing an equation. How far will it travel in 5 minutes? Does anybody have an idea on how you would do this one?
No.
R equals 2.
I think I got it too.
Okay. Yeah. So however you want to write. So she's saying the rate is 2.35 and M. She wanted to use M for minute. They didn't tell you what to use. They used T for time. I'll be able to tell whatever variable you pick. Okay. You use what? If you can use Y and X. A lot of times we'll use that. Does everybody get that? 2.35 per minute. So then there's a second part. How long or how far will it travel in 5 minutes?
11.7.
So you would just plug in 5, right? Use your calculator. Rate is 2.35 times 5 minutes. And what did y'all get?
11.75.
11.75 what?
Minutes.
Feet. 11.75 feet. I was just making sure you knew what. Because it's saying how far. And they're going to tell you right here, that's how far. How are we feeling? Good? It's not so bad yet? If you need help, I'll be here 4th block if you need some extra help. All right. Are we still writing? I'll leave it. Okay, number 13. Okay, it wants us to show what mapping diagram is represented. Okay, so yes. Oh, you have the answer? Yeah. Is everybody ready for the answer? No. Let's give them just a second. Let me give y'all a second. I'll pause this. Okay, so you list all the x values in the left side. What are all the x values? That's also known as your domain, right? Okay. Then in the range, the y, they're all -6. So you just write your -6. Then you just say -3 goes with -6. -1 goes with -6. And so on. You can tell, yes, these match. They look like they're the same. But one of them says it's not a function, and one of them says it is a function. Do any of your x values repeat? No. So it is a function. And that would be what? That would be B. It is a function. Do I need to explain that again? We're good. Okay, number 14. This one, it's a plug-in. You're just plugging in a number. So, how many jumping jacks can you do in 5 minutes? So what do you do with that 5? Just plug it in. 39 times 5. Can y'all do y'all understand what it's asking on that? Okay, what'd y'all get?
195.
So you got A. Everybody got 195 jumping jacks. I'm hoping that there's like really easy problems like kind of scattered throughout for y'all. Okay. 15.
How long is this study guide?
It's 31, but remember I'm about to take 3 questions off because there's 3 things that y'all haven't learned. All right, this one's kind of weird. It's got a word problem, and you have to think domain and range. So they're trying to trick you on some of it. You have 8 cups of flour, and you can make 24 cookies. Your 8 cups of flour is your domain. Y'all, this problem, I believe, is identical on your test. It might change the numbers, but it's still talking about flour and cookies. This is the flour. The F is the flour on every one of these. And your Y is how many cookies it makes. So you can have from 0 to how many cups of flour? What'd they tell you? 8. So you're looking at 0 to 8 cups of flour. That's your domain. Now, what does this one say?
0 to 100.
That's not even making sense. You're having 0 to 8. What does this one say? 24 to 192. That doesn't make sense. It's got to be one of these. Oh, wait, but this one we can already tell is messed up. Because you can make 0 cookies. I do that all the time. Like, I'll just decide, I'm going to make cookies, and no, I don't. So I end up with 0 cookies because I didn't even begin. So you can have 0 cups of flour, 0 cookies, okay? And then you already know your answer. Does everybody get that? Like, we've already eliminated all of them. But if I use 0 cups of flour, I get 0 cookies. If I use 8 cups of flour, how many cookies do we have? 192. So that's your range. And then here's just the graph that matches it.
So
So it is B, yes. Do I need to explain anything else on that one? We kind of get that? You're just going to need to remember that your flour is 0 to 8. And look, they use, actually,
Can you do another one? Yeah.
no. Another one of these.
Yes, please.
Oh, yeah, that is correct. Let's see. If I had, do you want me to just change the numbers? Because it's the same type of problem. It's still doing flour. Actually, let me just see what it says on here. Okay, so they say 11 cups of flour makes 264 cookies. All right, so 11 cups of flour. So my flour's between what? Two numbers. I could have 0 and I could have how many cups? 11. Does everybody understand that? Now, how many? I have no idea how many cookies I just said.
Look, 190.
264. Let's go with 260. I think that's what I said. So how many cookies can it make? So we can go from 0 to 264. And instead of just C, they use this little C of F thing. But that stands for cookies. So my flour can be from 0 to 11 cups. And my cookies can be from 0 to 264. Yeah. Yes, you may. Does that kind of help y'all? If it was, do I need to do another one?
So your dough line is always going to be the flour?
Yes. Yes. Because how many cookies you make depends on how much flour you use. All right. Are we better? And I know it doesn't include the graph, but really that's all you need to see your answer. Okay? Yes, no, you want one more?
I didn't have one of the shows today.
I'm about to go through it. If I need to do another one, or watch the video, y'all, if you circle it on Thursday, you're going to have plenty of time to do this test. So if we need 20 minutes of a review, like I'll go over them again. 16, is there a pattern? Okay, let's see. From 24 to 22 to 20. What are we doing? Yeah. So your pattern is you can write subtracting 2. You could put a little minus 2. Okay? And then what are the next two terms?
16 and 14.
Very good. 16 and 14. Just don't forget to read the directions. Okay? Because if you put this, that's only half credit. I also need this. This one, what are you doing to go from a negative to a positive to a negative to a positive to a negative? You're multiplying by something. Multiplying by -1. Multiplying by -1. Do y'all see that? We're just going back and forth and back and forth. We're multiplying by -1. That's your pattern. So, even if you couldn't, times -1. I might say that, times -1. That might be how I'd write it. That looks very confusing. Anyway, times -1. Maybe you just need to write. Times -1. Something like that. Okay, but then what are your next two terms? -5 and 5. That's half credit. If you couldn't figure out that this is what you were doing, you can still get partial credit for writing the next two terms. Does that make sense now, Chloe? Good. I think we're going to finish. I've been very worried about finishing this today, but I think, yeah.
If it would just keep going, it'd just be -5.
-5, 5. -5, 5. -5, 5. Yep.
Number 18 and 19, the ones that we're not doing?
I think, yeah, 18 and 19 we're going to do, but not 20 and 21. So take off 20. I told you they looked confusing. You're taking off 20 and 21, but 18 and 19, all it means is, are you adding the same number every time? If you're not, then it's no. Okay, and I'll remind y'all on Thursday. So on number 18, what are we adding every time? 4. So is it arithmetic? Yes. And it would be 4. Kind of like, you learn arithmetic, you learn adding.
So it's just like
and,
it stays and it keeps doing the same thing?
yeah, as long as you're adding or subtracting the same number, right? Adding or subtracting the same number every time, then it is arithmetic. Okay? So number 19, it looks like we're adding 5. What's 7 plus 5? 12. What's 13 plus 5? 18. So it's just no. Like we're not adding 5 every time. So it's no. Are we okay with those?
Yes.
Okay. Because I know I didn't teach that yet. That's really something we'll do next. But 20 and 21, I think that was way too difficult to teach today, along with all the domain range. So we're leaving that off. 22, you're basically describing what's going on. What's the first thing it asks for, though?
The variables.
The variables. That is part of your credit. What are they? Time and number of handbags. Okay, so you're going to put time and handbags. Those are your variables. Okay. Now you're going to say what's going on in the graph. So for a little while, how many handbags does she have?
I don't know.
Too many.
We don't have numbers.
So, well, it doesn't have, but it says it shows the number of handbags that she made in one day. So the first day, all day she didn't have a handbag. So I'm guessing she spent a lot of time making it, and then all of a sudden at the end of the day, what? She had one handbag, so it jumped up to 1. Does this make sense?
Yeah.
Then for a little while, or I guess this was all in one day.
I just said she kept making them and taking a break. And then she
Yeah.
went for the day.
You could, but to me, I'm thinking, so if she's making it, she doesn't have any made yet, right? Like, so right here, I'm saying she's making a handbag. And then,
All the time.
that's all the time it took to, maybe she did take a break, but that's all the time she spent making the handbag. Then all of a sudden, yay, she finally has one made. Right here, there's one made. But then what else is she doing? She's still making a handbag. There's one made, and she's making another.
What does that say? One made and making another?
Yeah, it's kind of, one made and making another. Then all of a sudden, what happens right here? How many does she have now? 2 made. Oh, scoot, like that? Okay. So right here, she's just making a handbag. She didn't have any. Finally, she finished it. So she has one made, and she's starting to make another. Then she finishes it, right? So now how many does she have made? 2 are made and making another. For all that time. Does that make sense? And then finally she has what? 3 handbags made. And I'm thinking she quit for the day. Because that's a long while. So she just has 3 handbags made that day. Yeah, now, and then maybe she'll have 0 tomorrow after she sells them all. I don't know.
What part of them?
Is everybody okay with this? You just need some type of story that matches what's going on.
You either write a story or do the
Yes. So if you're more of a writer, you could just write that out. She started off with 0 handbags. She spent time making one. Once it was done, she had a handbag, and then she's making more. Like if you want to write a story, that's fine. Okay.
So when it just goes flat, we have to write
I want to make
it
sure
out.
to start
Done
with
for the
the
day.
stupid little variables.
Oh yeah. 3 made and then done for the day. I like that. Done for the day. That's good. Done for the day. She is tired of making handbags.
It's cold in here.
Y'all are cold now? Okay, I'll turn it off. All right. Everybody, some of us still writing? We're good? Okay. Let's keep moving. This one, see, this is the same thing we've already done, right? Say that you didn't know how to do the one that we had earlier. You forgot how to graph. Maybe when you get to this one on your test, it would remind you what to do. What do? They give you 3 numbers. What are you going to do with these 3 numbers? Plug them in, and then we can graph on here, right, and draw our line. So if I plug in -1,
You can't even go up to 7. I just went up on my paper.
oh, because there's not enough room?
-1 is 7.
Oh, yeah. Well, we
That's
might.
what mine looks like.
So this should be 11 plus 6, which is what? 17. Yeah, that's way up there. Okay, let's plug in 0. -11 times 0 is what? 0 plus 6. Yep, you're right. It's 6. That one we could definitely graph. Okay? Then my last one, I'd plug in 1.
-17.
What did I just do? -11 times 1 plus 6. What did you get on this one? Should be -5, right?
Yeah, would it still be a straight line? I can't really tell.
It should be a straight line, yes. Now, if you don't want to graph that third point, you don't have to. You really only need 2 points to make a line. Okay? Only 2 points to make a line. So, but if you have the other one, that's fine. at least include it on your table. That is the worst line I have ever drawn.
It's beautiful.
Ever. That was awful. We'll just do it like this. Okay.
Alright, I did 24
I don't know. I'll think on 25. Number 24. We've only got 31. We're doing good. Oh, wait, do y'all need a second? Do y'all need to see these numbers?
Bryson needs a second.
Okay. I'll pause this. 24 is actually a real formula. You know, we have Fahrenheit and Celsius. What does America use? Fahrenheit. We use degrees Fahrenheit, and other countries use Celsius. So they have a formula that can help us to know, what's in Fahrenheit, and maybe you can convert it to Celsius or whatever. We're going to write the formula. That's what they want us to do. If you know the formula, then you'll get it right. But you just follow along. Fahrenheit and Celsius are two measures of temperature. Degrees Celsius is equal to, so what am I going to write?
5.
C is equal to, is everybody good with that? And then 5 ninths. What is 5 ninths? I'm just going to write 5 over 9.
32.
Okay. Now, of means you're multiplying. But I'm multiplying to more than one thing. So what do I use? Parentheses. And if you go and look up the formula for degrees Celsius, this is what you're going to see. And it says 32 less than Fahrenheit. So I'm going to say Fahrenheit minus 32.
You do 32 minus what?
Nope, you cannot. Because that matters. When you have a subtraction sign, it matters. It must say 5 minus. Is there a ladybug?
It was a ladybug.
Yeah, look in our corner up here.
Oh,
Jeez.
I want one.
Oh my gosh, I have one in my house.
There's like an
I was
infestation.
standing in my yard today with my dog.
Actually, I think they're Asian beetles.
Scare you?
So I think they stink and they bite.
That's the Asian beetle.
Yes, they.
All
right.
And they bite.
That's what I hear. They're Asian beetles. They're not really.
The Asian beetles
Ladybugs.
are orange.
Yeah, that one was orange.
Yeah, I'm thinking these are.
There's the orange ladybugs and red ladybugs.
Okay.
The orange ones are
26. Oh, yeah, we're recording. This is interesting. Domain and range. What's my domain? This is how I would list it. I'm just going to write it. What are all my numbers that are my domain?
-9, -4.
Okay, keep going. -4, 3, and 9. There we go. See, this is not a bad problem. You just have to know what it is. What's the range?
-2.
Okay, so 2, 2, 2, 2. Oh, they're all 2s.
Oh, never mind.
It's your Y value.
I'm just kidding. That was my dash.
Is everybody good with that?
Okay, that's it. Could you not put 2?
No.
It doesn't say, is it a function or any of that. All they want is your domain and your range. So that's 26.
Nowhere close to being done.
How will you know?
We're not close to being done. We've only got 31. Some of their
Oh, wait, I
pictures.
have one more page.
Yeah, but numbers.
Okay.
We have 4 more questions.
27. Is this a function? Does it pass the vertical line test? Yes, because only 1 point for each one of them. So yes, it is a function. 28 also asks for the same thing. Is this a function? Like if you can't find your directions Thursday on your test, just make sure and ask me. So 0, -5, -3, -5. Here's your problem right here. The -5 repeats. So no, it's not a function. Okay? Number 29. Man, we're speeding up now. 29, we have 2 times T is the number of guitar lessons that you can complete in T months. How many guitar lessons can you complete in 7 months? 2 times 7 is 14. So you would say 14 lessons. Okay? How are we with that one? Like, I think there's 3 of those so far that we've done where you just plug it in.
Oh, I must have done it wrong because I had just the way.
Okay, are we ready for 30? Now, 30, they give us some x values because the domain is your what? It is your x. You're going to plug those in and you're going to find your answers. How many answers are we going to have?
1, 2, 3, 4.
4 answers, because how many numbers are we plugging in? 4. So let me do that. I'm going to write -2 times -1 plus 6. Does everybody know where I got all that? Yes. Right there. Okay, what is -2 times -1?
2.
And 2 plus 6 is 8. So right here, I'm going to write my first number in my range.
I put mine in order.
Yeah, if you want to do that, or however you list them, as long as I can tell that you found your 4 answers. So what's my next one I'm going to plug in?
3.
A 3. So -2 times 3 plus 6. Well, what is -6 plus 6?
3.
0.
0. JK.
-6 plus 6 is 0. Then what am I going to plug in?
7.
7. -2 times 7 plus 6. -14 plus 6, which is what?
-8.
-8. All right. Then I'm going to plug in my last number, which is 9. Am I going too fast?
Yeah.
Okay. Let me stop for a second. Catch up, and then I'll go over the last one with you. You're caught up? So what we're going to do is plug in 9. So I write -2 times 9 plus 6. So let's do that. -2 times 9 plus 6. I write that down. Go, slow down. So what is -2 times 9? -18. And then I write my plus 6. And what is -18 plus 6? So that's my 4th answer. If it was multiple choice, I would write that in order. I would write -12, -8, 0, 8. But if you write it like this, I'm not going to take off.
Hey, is it okay if I did like a little, I did that to get on with
Yeah, that's perfectly fine. Yes. She wrote hers as a table, and that's great.
I started.
Yeah, so as long as I can, Yeah. So she wrote hers. I'll just show y'all while y'all are writing this down. She did hers like this. Hey, I'm plugging in my X's and I'm finding my Y's, and she got this. And y'all, guess what? I can tell what her range is. That's another way. I can tell that's her Y value. I'm good with this. I'm good with this. Okay? The next one is the exact problem on the test, so y'all might want to pay attention.
So you want to do this
I've got papers everywhere. I think this goes here. All right, are we ready for the last one? Listen, if you need help, you can come see me today.
You don't have to do that X and Y chart.
No, I was just showing y'all that's what like 3 people said that they did, and I was saying, yes, you can write your answer like this or like this. Okay? So if you need help, come see me today or tomorrow, 4th block. Test is Thursday. All right, last one. Sketch a graph of the speed of a city bus on their daily route. This is the speed, this is the time. Y'all, please notice as you read this, what's going to happen with the speed of the bus? It's going to go up and down, and it may stop, and it may keep a constant speed. That's what I want you to keep in your mind. So, the bus pulls away, and then it starts to increase speed. So we know it's stopped. So my speed is 0. Then what happens?
Go up.
It's going up. My speed increases. And then it's at a constant speed. So I would represent it like this, right? Does everybody see that's a constant speed? Then what happens?
Goes up.
Well, we did go up, but it's not going to speed up anymore. It's stopped. So does it just stop like that? Not unless it wrecks, okay? So it's going to slow down and stop. So let's slow back down, and it stops and it picks people up, right? Then, oops, I didn't mean to go below my line. Then what happens? It does it again and again and again all day long, right? Does everybody kind of understand this? So, and you could have drawn your graph bigger, higher up or whatever, but so then it increases speed, then it goes up, it stays at that constant speed, then it comes back down all day long, right? Does that make sense? It's going up.
Yes.
and then it comes back down and it stops. Okay? It does not stop instantly. I recorded this for y'all.